Right, we're carrying on with this electrical worksheet or exam questions. Right, a student uses circuit shown in diagram to investigate how current changes with voltage for a filament lamp. So this is our lamp. Our voltmeter, have you noticed, runs parallel. It runs parallel to the filament lamp because we're measuring the voltage across the lamp. Look, across it. Yeah. Ammeter measures the current in the circuit because it's a series. It's just one big long wire. You put it there, and this component here, this one here is a variable resistor. So remember, a resistor is like this, and a line across it tells you it's a variable resistor. So you have like a little dial, and you can move that left or right to increase or decrease the voltage here, across here, which increases and decreases the voltage across here. That there is your battery or cell. It's single, so it's a cell single. The long side is the plus, the short side is the minus. Okay, now that's that done. Let's rub all this out. So what they're saying, give the name of component Y. We've already said that. It's a, is it? Yes, variable resistor. Right, give a reason why component Y is included in the circuit. So it allows the, just stick to voltage. It allows the voltage across the filament lamp to be varied. So they've emphasized varied. Do not write it, it allows you to change resistance, although that's how you vary the voltage. So remember, look, keywords, yeah, it allows a voltage. You can say voltage and current, or voltage or current, to be varied across the component, across the lamp. Right, okay. The graph shows some of the students' results. Right. Let me just go through this with you. There's 3 graphs, just looking at the book, that you have to learn. 1, 2, 3. It would be probably nice to learn them like this then. So you've got current, and this is voltage. So current, voltage, current, voltage. And you have to do it that way because then the gradient is the resistance. Right. So this one is going to be for a wire or a resistor. This one is going to be for a filament lamp, or okay, filament lamp or bulb, and this one is going to be for a, let me put it down here, diode. That allows flow of current in one direction only. Yep. Right. When you've got this one, so just watch this. So you've got to put these all into, commit them to memory. you've got a straight line, goes through the origin, and it's a straight line. Right, with this one, so you've got it goes up and then it curves off like this. Right, this is what they've highlighted. The gradient here tells you it's low resistance. The gradient is low or lower. You have high resistance. And then so you've gone down, and it tapers off like this. Right, now finally for the diode, we'll do it blue. You've got high resistance, so the flatter the curve, and then at 0.6 the resistance just suddenly takes off. So here you've got low resistance and it starts working, allowing current through resistance. And when it's flat, so this point, okay, when it's flat it has high resistance. That number there is 0.6. So if you can learn these three, you're on your way. Right, what can we do with these? If we somehow get rid of that, do we somehow take a screenshot? Let's take a screenshot. There you go. Let's dump that. Right, it's saying state the formula linking charge, current, and time. So what you do is obviously get a pen. Charge equals current times time. So if you've got a certain amount of current going through and you're using a lot of time, you're giving it a lot of time, you get a lot more charge through. Right, determine the current in the lamp when the voltage across the lamp is 10 volts. So 10 volts is here. We go up. And we go across. So you're using a ruler, put these two lines in using a pencil, and you should get 0.48, because look, this here is 0.5, so we're expecting 0.48 amps because we're expecting current. Calculate the charge transferred in 30 seconds. Okay, so we know the formula. Charge equals current times time. Right? They want us to work out the charge. We know the time is 30 seconds. Time has to be in seconds, not minutes. Just bear that in mind. Current, we've just worked out as right, and you've got 14, and they've said give the unit, so that'll give you a mark, so it's coulombs. C. Yeah, coulombs. Right, calculate the time for the lamp to transfer 250 joules of energy when the voltage is 10. So there's a formula which we've got, which is E equals energy equals voltage times current times time, VIT. So that's how you can. So look, this is the thing. You're gonna have this, but if you keep repeating this, you'll pick out the right formula. The danger is if you just rely on the formula sheet, you're gonna pick up, and you just get frustrated. So the voltage is 10 volts. The current right, it's the same lamp, same current here. So 0.48, and we're trying to work out the time, and we've been given the energy 250. So you have to write this, and then you put this into your calculator, put this bit into your calculator. So what I'm going to do is I'm going to go over here. So I've got 250 equals 4.8 times t. So I can put t equals 250. So I'm showing all my working out at every stage. Yep. Equals 52 seconds. Right, the student disconnects the cell. So we are down here now. So we've done that bit. The student disconnects the cell and reconnects it with its terminals reversed. Complete the data graph to show how the current in the lamp varies with voltage across the lamp when the cell is connected with its terminals reversed. Right. Remember this. Right. Remember this, it's a filament lamp. Positive voltage, it does that. Negative voltage, it'll do that. So what we do is we just carry this on and do it in reverse. So 12, it'll be minus there. That's what we're aiming for, and we're trying to aim for, yep. So we're trying to just copy, we're trying to copy this in reverse. So this is what we're trying to do. There you go. So that's what it'll look like. Yeah, the key thing is that it finishes here, like it finished at 12, 0.5. It'll finish at minus 12, minus 0.5. Right, that's that bit done. Right, here now, the student replaces the filament lamp with an LED. So this here is an LED. It's a light emitting diode. You can see these arrows pointing away because it's emitting it. It's not dependent on it. A light dependent resistor has arrows coming towards it because it depends on the light, so the light has to come to it. Right, okay, so that's a light emitting diode. Let's get rid of that. Right. And replaces the cell with an alternating current. So a cell has direct, if I can spell current, direct current. It goes in one direction and it's steady. The power that comes out of the plugs in the wall, let's just use, or the sockets in the wall, should I say, it's AC, alternating current. And replaces it with alternation. The student removes the ammeter and voltmeter from the circuit. So can you see this symbol here? That tells you it's an AC the supply, alternating current supply. Explain why the LED flashes on and off in this circuit. Because the current is changing direction, so the current is moving in that direction and then that direction. As it moves in that direction, it's fine, but it will not allow it to go back, so it will go off. When it's going in that direction, it'll go on. Right. 2 marks. Right. The current is changing direction. The LED only allows current in one direction. So the LED only lights up when current is in forward direction and goes off when current is reversed. There you go. Right. Yeah, we'll call it quits there.